Hello, algebra students. Okay, we're back. It's Tuesday, I guess. No, I don't know what day it is. Okay, I'm losing track of time. But let's get to work on this group practice here. Now I got 3 problems. They look really, really complicated, especially if you haven't seen them before. Maybe some of us had. They won't be intimidated as much. Now, let's try to simplify these because these are kind of annoying. A is going to be probably the easiest one in this whole bunch. Now, number 1. First thing I'm going to tell you is this is just a lazy way of writing this problem. Another way you could write it is you could say square root of 144 over square root of 9. For all 3 of these problems, you can do it. You could solve it as the top problem and a bottom problem. Okay, so that's fine. Solve it as a top problem and as a bottom problem. Now, if you remember your perfect squares, 144 is a perfect square and 9 is a perfect square. So as I'm listing my perfect squares, I'm going to start with 12 times 12, which is 144. 11 times 11, which is 121. 10 times 10, which is 100. 9 times 9, 81. 8 times 8, 64. 7 times 7, 49. 6 times 6, 36. 5 times 5 is 25. 4 times 4 is 16. 3 times 3 is 9. 2 times 2 is 4. Remember, we really don't use 1 in this problem. So look at this. I have 2 perfect squares in this problem. This and this. Now, if I just run this into the calculator, if I forget, and I put 144 in the calculator. Let's say I put a square root of 144. It comes out as a decimal. I know I have to do some sort of simplification of square root of 144. It's not going to happen in this case. Same thing with square root of 9. If I put both of them here, second square root 144 is 12. So the top number is just 12. What's the bottom number? Well, we take second square root of 9, 3. Look at that. So 12 divided by 3. Well, 12 divided by 3 is a whole number. 12 divided by 3 is just, if I put it in the calculator, 4. Okay. So the key to these problems, there's 2 keys to this problem. Number 1, we already did simplification yesterday. Okay, so you do know how to simplify these, especially if they get more complicated than these. And you can simplify the fraction. Never, ever will you get a decimal in these cases. You do not want, you do not ever want to have decimals. Never decimals. Okay, so the answer is always you want to leave it in radical or a whole number, but nothing ever in between. Okay, that wasn't too bad. Okay. All right, so let's start this next one. All right, with B, same problem. Okay, so it's really 2 different problems. I'm going to look at them this way. Square root of 36a and square root of 4a3. Instead of writing the 1 big, I write the 2 little ones. And so, well, I'm just going to solve for these. Make it pretend it's 2 separate problems. Well, 36 is a perfect square. If we remember down here, 6 times 6 is 36. So that's good. And I have square root of a. Okay. On the bottom, I have a square root of 4, which is another one of our perfect squares. So always write these down. This is not a bad idea for doing these problems. And square root of a to the 3rd power. Okay. This is not bad at this point. So 36 square root of 36, if I do that in my calculator, I get the number 6. Square root of a. Remember, we only could do this if it has an even number exponent. Square root of a has just a 1. So I'm just going to leave it there. Can't do anything with it right now. On the bottom, square root of 4. Well, square root of 4 is just 2. And then I have a to the third power. Something I can't do anything about. All right. We're getting good here. Now, next step. Well, 6 divided by 2, that's pretty easy. 6 divided by 2 is just 3, so I can work with those. So now my problem looks like this. Now, if you remember from yesterday, the a to the third can also be looked at as a squared and a to the first. Now, if we remember what 1 divided by 1 is, it's just 1. So square root of a and square root of a are the same numbers. Even though I don't know what the square root of a is, I know they have to be the same numbers. So I literally can cross those out. So my next step, I'm going to move to the side here, and I hope the other one's not as hard. I'll have 3 over square root of a, square root of the square of a. Square root of the square of a, remember, you just take 2, and we cut it in half. 2 divided by 2 is just 1. So our final answer is 3 over a. Now, one of the big rules with these problems, you cannot have a radical in the bottom. So if it's a bottom radical, if this would have stayed a square root of a, we would have had to do something about it. We kind of got lucky that it didn't, but it's just 3 over a. Let's look at the next one. Okay, so this one, remember, this is really square root of 25, square root of y to the third. The bottom, it is square root of z squared. Okay. Square root of 25, again, I look over here. It's one of my perfect squares, and that's just 5. 5 times 5 is 25. You can put it in the calculator you want. This y, I'm going to change because it's not an even number. I'm going to make it y squared and y. On the bottom, I have z squared. Well, z squared is an even number. 2 is an even number. 2 divided by 2 is 1. So it's just z. Y divided by 2, as we move to the next step, is just y. Y divided, actually, the square root of y squared is just y. This, I can't do anything about. Leave it like that. All over z. That's our final answer. I check to make sure there's no square root symbol or radical symbol on the bottom, and I just leave it. Okay. I'll be back with the independent practice.